Started. Hello everyone, this is Dave Sly from Proplanner, and today we're going to look at using the Tugger module in Proplanner and kind of highlight some tips and tricks on how to make the most out of Proplanner Tugger analysis. The trick with a Tugger analysis is that you are pre-processing your routing file. So it's important that you understand how to use Proplanner's basic unit load routing analysis capabilities. I'm going to just highlight that user interface here in just a moment. You'll see it being populated, but this is basically where you identify your part that you're moving, your from, your to, your method, and so on. Now with a unit load analysis, you're also specifying a frequency of trips. With a Tugger analysis, we're actually defining a route. So the idea is that the route will start and end at the same location. This is a circle of work. And we're picking up and delivering at multiple locations throughout the facility. Now, of course, you could create such a circle of work or route on your own in the routing editor here of Proplanner in Excel and import it in. But what the Tugger module does for you is essentially creates those various circles of work based on what it is you wish to deliver. So it starts over here on the Tuggers tab by wanting to look at what is it you want to deliver. So I'm going to grab an Excel file, which is a delivery file. Now, one of the things about the Tugger analysis it's important to note, and we'll do foot-inch Tuggers. I'm just going to use the tutorial, okay? So foot-inch tutorials. And we'll grab a Tugger analysis. Sorry here. Okay. And this file is CSV, just like the routing file. The idea is that it's easier to load into Excel and edit. But of course, the routing file, which is generated by this, is also a CSV file. So when you save your routing file, it's very important that perhaps you might want to make a copy of your Tugger file under a different name so you don't accidentally save over it. It's a common thing that can happen. But we felt that it was important for the two to have the CSV extension since they're often loaded into Excel. We also have a methods file which identifies the equipment that we're using, containers, processes for load unload, as well as a location file, of course, for your location assignments. So I'm going to go ahead and load those three studies. Now remember, when you do this the first time, you may not have an MHE or a loc file, and that's fine. You can check those off. It will create those for you by default, and then you can edit them to be more specific to what you want them to be. So we've now loaded our Tugger routing file, our Tugger delivery file, technically, that's going to be used to generate our Proplanner routing file. As I said, the Tugger file is a set of deliveries. So what we have here is a set of parts on the left with a line ID, just a transaction ID. The ID has nothing to do except if there's an error, it can tell you, oh, on this line. So it's typically a sequential number. A part number, which can repeat, by the way. We can see that we have 111847 on this second row, and we also have it on the 9th row. The container being delivered, the container quantity delivered per delivery request. The from location, the staging location, and the to location. Now, if you think about it, most Tugger deliveries are like a figure 8. We start at a warehouse door, for example, which might be our staging area. We go into the warehouse and we pick up this box with part 111847 in it, as well as a number of other things, in this case in the receiving area. These are different receiving locations. We fill our Tugger. We then come back to stage, and then we leave. We go out and we do a set of deliveries. Now, the order that I pick things up in and the order that I deliver things in will not be the same. The software the Tugger module in Flow Planner, we use the traveling salesman problem along with the aisle routing algorithms, Dijkstra's algorithms, to find the shortest path and therefore the best sequence with which to both fill your Tugger as well as unload your Tugger. Now remember, with a routing file, it's important that your rules of a good routing file, that your part name, your container name, your from to names, staging names, don't have any special characters in them except for dashes and underscores, and they can just have text, letters, and numbers, no spaces. So make sure that you're conforming to those rules. Now, it's possible that your Tugger study is really just from the staging area. You're assuming that the carts are already filled by someone else that's outside of the scope of the study, and that you're going into the factory to drop things off or pick things up. If that was true, then you have just the stage and the to specify, and you leave the from fields blank. The other option is that this study is just about going from stage with empty carts, going into the warehouse, picking up material, filling your carts, and coming back to stage with full carts. In that case, you leave your to blank. Finally, some people have asked to do a unit load study. You know, I go here, pick up a load, and then I go here, drop it off, then I go to the next closest location to pick up a load, then I drop it off, then I go to the next closest location to pick up a load and drop it off, okay, of all the things that have to be delivered in a given day. So in that particular situation, what you would do is you would leave stage blank, because there's no stage. You're just doing a lot of from tos. It's like auto routing your unit load study. So that's really what the Tugger tool is going to do. That's what the delivery file is about. Now, the other thing about the delivery file is we need to understand when we want this delivered. Remember that a day is broken up into decimal hours. So 8.1 hours, 8.8 hours, 8.9 hours, 7.1 hours. Those are decimal hours. So the Tugger module works only for a 24-hour cycle. So we're evaluating one day at a time, but we're evaluating an exact day. And so the software is going to actually either schedule or not schedule a delivery. There is no percentage of delivery like there is in the Flow Planner routing editor when you're doing unit load deliveries. You know, in that editor, if I specify that I'm delivering 100, I have a container of 100 parts, but I only need 50 for this time period of my study, then it's going to do half a load. It's going to do a half a load of something else. And of course, collectively, I statistically end up with time and distance appropriate to an average week. So where the routing editor typically will average your unit load deliveries, the Tugger module works more like a simulation application. It is going to use a random number seed, you can see that down here, to determine a sequence of numbers that will be used statistically in deriving whether a load is delivered or not delivered. That's, of course, if you use a statistically derived delivery. So you can see that in my estimated time of delivery column for this particular delivery, on this case of part 111456, from receiving to via stage to the hole punch area, that's occurring at 7.1 hours in the day. Okay, so 7 o'clock, about 7:06 a.m. And that's going to happen because that is a fixed time that I've specified, and it's going to happen once. On the other hand, I have this one that's statistically derived. A uniform distribution, which just means equally likely that it will be happening anytime between 7 a.m. and 10 a.m. So somewhere in there, I'm going to have 2 deliveries scheduled. And each one of them has a 50% chance of occurring. So I could have 0 deliveries, I could have 1 delivery, or I could have 2 deliveries, right? That's what that means. 2 deliveries, 50% chance of occurring. Depending upon my random number seed, I'm going to get one of those outcomes. And I will get the same outcome every time if I use that same seed. Once you've done a Tugger analysis and you generate a routing file and you've studied it and you've looked at your capacities and your layout and all, you certainly want to go back and generate other hypothetical days using different random number seeds, which will cause these statistically derived deliveries to either happen or not happen or happen at different times. And what you're doing is you're checking to see the sensitivity of your study. In other words, yeah, with this random number seed, this exact occurrence of events, there's no problem delivering all of your materials. However, on a different seed, a different combination or possibility of things that may happen, that may present a very difficult day. And of course, if your system has a lot of variability, which can happen if your load sizes are large, they take up a lot of place in your Tugger, you may need to do some changes to your system, to your Tugger carts, to your containerization. You may want to move some materials to be delivered with fork trucks as opposed to Tuggers. Tuggers work usually best with small lot deliveries if it's more of a random selection of things to be delivered. Unless, of course, you're doing a tow train of like just doors or just seats. That's more of a sequence delivery of that item than it is small lot Tugger delivery, which is really what the Tugger module is primarily designed to handle. This next one here, it says 7 a.m. to 10 a.m., one delivery with 100% chance of occurring. So that's going to happen. I just don't know when. Okay, it will happen sometime. One delivery will happen sometime between 7 a.m. and 10 a.m. Okay, now the direction attribute or variable here, a 1 means that I pick up at the from and I drop off at the to, but a -1 means I am dropping off at the from and picking up at the to. That might be, for example, scheduling the pickup of an empty, something that you could do. Now, normally the load unload time of a delivery will be specified by the methods tab. So I'm specifying in my Tugger routes, which we'll talk about next, a particular device that's going to be used for these drivers, zone 1, zone 2, and zone 3. So if I go to my methods tab, you'll see I have zone 1 and zone 2 at the moment scheduled, and I've specified tug as a device. That's my method type, and I've given it my aisle path and my speeds. I can type in a load and load time as a fixed value, or I can define a process. In this case, I've identified an unload process that says whether the container is full or empty, do this. If the container is full, do that. Only if it's full, do that. And that's 15 seconds per stop, 15 seconds per container at the stop gets added if it's a crate. Or if it's a full container, 15 seconds per stop, 9 seconds per container if the containers are a box. So I've specified what to do if it's crate, what to do if it's box. Now, CX means whether the container is full or empty. A CF would be full and CE would be empty. So I can specify processes. And this is covered in the basic routing functionality of Proplanner. But my point is that I can specify these dynamic load and load times with these rules, these processes. And that's commonly done with Tugger studies because we have such a variety of things we're picking up, and we often are handling many containers at our stops. So it's important to be accurate with regards to that time. So I've identified my zone 1 and my zone 2 route drivers, and I've identified the type of equipment and the load and load times. But in the Tugger delivery spreadsheet, your input file that you're going to create in Excel, you can override those load and load times by hard code specifying a time. So if there's a value in here, as there is in this particular product that's being delivered, this 235448 at 7:06 in the morning, 15 seconds will be used for the load and 10 seconds will be used for the unload. Finally, I have route drivers, and you can see I've specified 3 route drivers here. Now, route drivers are specified in the locations tab. So I have all my locations where I pick things up and deliver things to. What I'm going to do is select some of these locations and go into routes here on the right. You can see my 3 route drivers in 3 different colors. I've created those. I can add and remove route drivers here. And I can specifically specify which route driver that I want to assign those to. And if I hit update, it's going to change those locations to using that route driver. What I'm essentially doing is, if you think about your mail delivery person, your mail people, your package delivery service, such as UPS or FedEx, has a certain number of addresses that they're responsible for serving. So I'm mapping the route driver to an address, to a location, doing this. Now I can do this by selecting locations from the list and mapping the route driver. Or I can go into AutoCAD, okay, and I can window an area of the plant, as I'm doing here. And when I do that, it may be hard to see, I don't know if you can tell, but the software has selected a number of locations that were in that geographical area. And now if I go select a route driver, that route driver will be assigned those locations. So I can do it by selecting, or I can do it visually. But it's important that your locations are mapped to a route driver, because it will use the route driver for that. And in particular, your delivery locations, your from locations are going to use the same route driver. So the software defaults, if you are doing a from, stage, and to study, to using the route driver assigned to the delivery location is that route driver who picks up the item in the warehouse. That's why in this case, my two locations, such as assembly and bore and deburring, are mapped to a route driver. But you'll notice my receiving locations are not. Even if they were, it's fine, you can have it, but it's just going to ignore them. Because obviously the person that delivers it has to be the person that picked it up. Now, if you're just doing a receiving study, that's from to stage, or you're doing stage to to, then of course you need to specify your route driver because it's going to be one or the other, for all your locations. But you also see there's a route column in this file. And this route column lets me specify a specific route driver to be used, regardless of the location I'm visiting. So even though in a locations tab, if I were to go to, let's say, hole punch, I could see that the hole punch, in this case, hole punch on order, is using the zone 1 route driver. Okay. But if I go into Tuggers, I would have the ability to say, I want to use zone 2, and that will force the zone 2 driver to go over there for that one specific delivery. So some people want to hard specify their route driver to their part or that they're delivering in their delivery file. And some people want the route driver mapped to a location, and wherever the part goes, it gets assigned a route driver based on the route driver is using that location. I would say the location is probably your more flexible option because, of course, I can easily go in and remap or reassign locations to different route drivers and run my study very quickly and easily. If I manually map my route drivers here to my deliveries, then it's not as easy to reassign deliveries or routes to other people and make sure that they're geographically contiguous. It means that they're kind of located together. Okay, the next thing that we want to look at in this file is I've identified when the route driver is working. So I have a route driver zone 1, 2, and 3. In this case, this route driver works from 7 a.m. to 1500 hours, which is 3 p.m. Okay? And they go out every 10 minutes, and I give them 10 minutes to do their deliveries. That's also very important because the Tugger module in Flowplanner assumes that there is a fixed delivery window. I go out every 10 minutes or every 15 minutes or every 30 minutes or however that's going to be. I go out every so many minutes. And so what it does is it divides the day, in this case 7 to 3, 7 a.m. to 3 p.m. up into slots. And then it looks at these containers that need to be delivered by that driver throughout the day when they need to be delivered. Software does that. And then it breaks those deliveries up into windows so that everything gets assigned one of these slots based on when it needs to go, what slot does it go in. So you can see that some slots could have a lot of material to be delivered and some slots not so much. And that's the reality of the dynamics of the environment we deal with, right? The other thing that I may have is I may be able to specify pass-through points. So here I've identified a couple of locations. Asterisk T means on the to location. I could also do an asterisk F, which are pass-through points on the from pickup. But asterisk T on the to delivery, when I'm going out and delivering things to the two locations, I want to make sure I'm going through points P1 and P2. Regardless of whether I need to go to that part of the plant or not, I want to go there. Maybe it's an area where I have to pick up tickets. Maybe it's an area where I have to drop off empties and I don't want to specify those in the study. I'm just assuming that, I'm by going by that area, the person's going to stop and drop things off. Okay, so those are locations that I've picked. The pass-through points do need to be locations on the aisle. So you want to make sure that you're putting those location labels on the actual aisle lines as opposed to off the aisle with the join line. The other one is the volume. So I'm specifying whether I'm using feet, and therefore my volume would typically be square feet, or whether I'm using meters, which would be cubic meters. I'm identifying, in this case, I'm using feet. I'm identifying for that particular driver how many cubic feet of material I have. Now, this is related to small lot deliveries. So obviously that means if I'm doing this, I go into the containers, I need to make sure my container sizes are specified appropriately. In this case, they're in inches. The software will find out the cubic inches, convert it to cubic feet, and that's how much that product takes based on the number of the containers I'm trying to deliver. Of each thing I'm delivering, it calculates the total cubic feet capacity of the tugger. Now we know that tuggers can't be stacked 100% efficient. So while I may have 300 cubic feet available, the question is that 100% volumetrically efficient? Can I use the full 300 square feet or cubic feet? If not, then I need to specify some sort of percentage or ratio of it, what I can use, okay? So the other way to do it though, some people say, you know, I'm not worried about square feet because all my containers are the same size. I just know that I can get 10 containers on a cart or 5 containers on Tugger. In that case, that's fine. Then instead of typing 300 cubic feet, just use the number 5 or the number 10. But that means in your containers that you need to make sure that every container is a cubic foot, 12 by 12 by 12 inches in the case of this, or 1 by 1 by 1 if you're using metric and you're using meters, or 1,000 by 1,000 by 1,000 if millimeters is your base unit and you're trying to get to 1 cubic meter. By making these all calculate out to 1 cubic foot or 1 cubic meter, causes the software now to just think in terms of integers. It says, oh, I have 10 containers or 10 cubic meters, right? That's where the volumetric efficiency becomes pretty important. Now, the other thing that's happening here is that I can identify a specific staging area for a location. So you see I have this name stage here. Now that could actually be the name of a specific staging area. But more often than not, it's just a generic name stage. And I could specify an actual staging area that this zone driver uses. So if each one of your Tugger drivers stages in a different location of the facility, which is common, then you assign the staging area here, and this will override whatever the staging area is that's been specified here in this stage column. The other thing I could do is I could make sure that when the program generates a route, that it also drops off empties at a returns area. So I can specify a returns area, and the software, when it generates a Tugger route, will actually add a return location to the end of that route so that I'm forced to go there before I can come back to the staging area. So oftentimes when we're doing Tugger deliveries, we're picking up empties along the way. We then drive by a returns location, drop off the empties, and come back to a staging area. So this does that. And then, of course, I can specify my staging time. I can also specify my staging time here. So if I choose not to specify staging area and returns and a staging time uniquely for every one of my Tuggers, I can specify that here, okay, what I want to use for staging, and the software will use this time globally if I haven't specified it anywhere else. And you can see on this one, for zone 2, I have specified a unique location for staging, but I haven't specified any of these other things. All right. I can also specify whether I want to include or exclude certain drivers. In this case, I'm going to exclude zone 3. We'll just do zone 1 and zone 2. Now, the other thing to keep in mind is that the software at this point is generating your delivery sequence for each one of the delivery trips you take throughout your available delivery time window, in this case, 7 a.m. to 3 p.m. So for each of those 10-minute slots, I'm going to get a set of things I'm delivering and the order I'm going to deliver them in. Okay. Now, to determine the order of delivery, the software needs to either use distance between things as straight flow or aisle flow. That may not be the same that I choose to do my flow study with. It's just using distance from the aisle network. And typically, when you first run a Tugger study, you may have generated your join lines. You may even be missing locations, and that's okay. But obviously, if you're missing locations, you're not going to specify your aisle network on your first pass. So what I usually do is I just do a straight flow study to start off with, and I do a fast algorithm. Now the fast algorithm is a TSP making a traveling salesman problem, making some assumptions about the sequence of things, where the accurate TSP algorithm is one that, and it's usually pretty good. The fast one is usually pretty accurate, but it isn't perfect all the time. The accurate one is more of a brute force. It could take quite a bit of time to get you that 100% accuracy, which may not be warranted. So usually I just use straightforward fast for my first pass. I use a random seed of 1, I'll put a staging time of 15 seconds, and I'm going to go ahead and generate routes and see what happens. So what the software is doing is says, hey, keep in mind, the Tugger module generates a routing file. That's its goal. So if you have a routing file, it's going to get rid of it and add this to it. So just telling me that's going to do that, that's fine. And now it's done. So what has it done? Well, you can see if I come up here, I've created a set of products. Now they're really not products, they are deliveries, okay? These are deliveries that are happening throughout the day. So 7 o'clock, and now in this case, the points are time windows of actually minutes. So 7:10, 7:30, 7:40, 7:50, 8 o'clock, 8:10, 8:30, 8:40, 8:50. Notice I don't have an 8:20. That's because there are no containers that need to be delivered. So, and you may have, so some of them may get missed if no container shows up in the deliveries file after we run our statistical calculations that it needs to be delivered. These are the deliveries for the zone 1 driver. So zone 1 driver, 7 o'clock, but we also have a zone 2 driver that goes out. Actually, the first zone 2 deliveries at 7:20. Okay, so the 7 o'clock, what happens? Well, we start off picking up part 11-111-332. We're leaving staging, and we grab this part at the location receiving for. Then we travel to receiving 2 to deal with receiving 4. Now in this case, my parts per container is either 1 or 2. So 2 actually indicates, in this case, a drop off at receiving 4 because it's a -2. -1 means a pickup. So that's how we computed the -1 and 0 that you saw before, or -1 and 1 for direction. And 1 container, and 1 container. Here's 2 containers that I'm picking up at receiving 14 of that part, 235, 448. And then I go to receiving 15 and pick up 235, 449. And then I go back to stage. Okay, so I started at stage, I came back to stage. I went through the warehouse, I picked these things up, and that's the order I picked them up in. I then went out into the warehouse or factory and ended up at T pass-through points first going through. Then I dropped off this part at bore, this part at hole punch, degreasing, metal forming, and stage. And metal forming, degreasing, I dropped off 2 containers, and I returned back to the stage location. So what the Tugger module did is it first figured out that this driver needs to deliver these things in this delivery window, the 7 to 7:10 delivery window. And this is the order that I should pick those things up to fill my carts in the warehouse. And this is the order I should drop things off. That's all the Tugger module is doing, is generating this routing file. And of course, you can save this routing file and do further studies on it as you wish. You notice parts per container isn't specified. Why? It's not relevant, because remember, the Tugger module is treating this as a circle of work. It's ignoring these negatives, tell the Tugger module, tell actually the routing module, when you do a calc, to ignore parts per container. This is a Tugger study, just route the materials straight through. Container per trip is important, because when we do load and unload, we need to know how many containers we're unloading and how many containers we're loading. Remember the processes I talked about? In the processes, you can specify time per stop and time per container. So in this case, if I had 10 seconds per stop and 10 seconds per container, that would be 10 seconds for the stop plus 2 times 10 seconds for the container, or a total 30 seconds for handling at that location. Or in this case, it would only be 20 seconds. That's one benefit of using processes for load and load time versus a fixed time when working with Tuggers. So you can see then at the next time, these are the things I'm doing. I'm only doing 1 part, right? Not much use for a Tugger. This one, I've got 1 part. This one, I've got 2 parts, okay, being picked up and delivered. I go to zone 2 driver, that's 1 part. Zone 2 driver wasn't very busy. Oh, there's a busy time for zone. See that all of these parts are hitting at that 1 point. Okay, hopefully that gives you some idea of what we generate. So remember, I did this quickly as a unit load study. So it's going to, if you had an assembly line, it could just zigzag to the assembly line. It's walking over the assembly line because that's going to be the closest point for the parts. But if I had instead generated, so my sequence of pickup and drop off may be wrong. That's why for the Tuggers module, if I had a situation like that, I would definitely want to generate this route sequence by using the distances computed by the aisle network. But as I mentioned, the very first time, you just want to make sure all your work center points are specified. So if you were missing any, it would prompt you and you would click points. You could then go in and do your calc, do your join lines, hit the join lines in the paths tab, join locations to aisle once all those locations have been specified. And then you go back to your Tugger module and regenerate your Tugger routings, but this time with your aisle routing. And we'll do that real quick. So here I've done my study. Remember, I did generate these sequences using straight flow. So some of these may not be actually in the right sequence. Although since I don't have assembly lines, it probably won't make much of a difference in this layout, whether they're straight flow or aisle flow. Long assembly lines is where we see a big difference and stuff like that. I can go do a straight flow calculation, or I can do an aisle flow calculation. It doesn't matter. I'll just do a calculation here, a straight flow. It's easier to see. And you can see the software is calculated for each driver at each time, how much time it took for that delivery. So 7 o'clock delivery took 546 feet. And the Tugger was 64% full, 33% of the time was traveling, and it took 0.09 hours to do the delivery. Okay. I can also, in my results, do what we call route-based studies, and it just totals up the total time for the different route drivers. Okay. And I told you I turned this one off, but I forgot to hit save, so it's still on. That's why we have a zone 3 driver in this case. All right. So I do have flow lines. Now the flow lines are 1 trip line, so the thickness is usually going to have to be factored up quite a bit. I usually use a number about like 500 to get lines that look pretty good, but it depends on your layout. Let's try 1,000 to get some nice lines. 1,000. There, those lines look pretty good. See the lines? Now what I'm going to do is filter. So the filtering works the same way. I can filter. So where is the tug driver going? Zone 1 driver and zone 2 driver first thing in the morning. Okay. And I hit filter flows, and that's the routes. So you can see there's 1 driver and the other driver out and back, only 1 part, right? So there was no real route in that particular case. I can grab one of these other ones that was kind of big for that driver. There's another 1 route. One of these was pretty big. I can keep adding. Look at that one. There's a lot going on that particular route for that driver. All right, so you get a chance to see what you do. So that is an actual route. Of course, even though I did generate the route sequence by using straight flow distances, I could still do the actual flow study to the aisles and generate my aisle-based flow studies, and that's what it's going to look like down there. Of course, in this case, my distances and times are much more accurate. The straight flow, they were way off. You can see these times are now much more in line with what you would expect to see. Now, one other thing that I often do, you can see how the software is routing the flow Tugger into the workplace. But in reality, most of the time, the Tugger is just simply going to go to the outside of the workplace, and the person's going to walk into the workplace. So what we want to do is we're going to tell the software to ignore aisle joins on the calc. See what I've done down here? Now what that will do is if on the settings tab, I actually have a walk speed specified, and I do, the software is going to take the join line distance that you see here into the workplace from the aisle line into the workplace point, the location label. It's going to take that distance times 2. It's going to factor in, divide by the 5 feet per second. And what I'm going to get is time to walk per container from the Tugger to here and back. That time, that walk time, so while it's going to remove this distance and time from the Tuggers transport and add it to the handling time, which means that my processes or my method load and load times need to account for that. I need to recognize that this is the time to actually pick up the container and place the container, because the walking in and out of the workplace per container is being addressed by using this walk speed and using that join line distance. But that's only going to happen, as I say, ignore aisle join lines for the Tuggers route, so that it then takes over and uses the person that's doing the walking. One other thing about that is it's going to take one container at a time. However, in the containers tab, I do have the ability to say full stack quantity, and I could do 2 or 3, which means this container a person can carry 2 or 3 at a time. If that's true, that's 2 or 3, then if I had 3 containers to deliver to this location, and that was a value of 3 for that container ID, then I'm only going to get 1 walk in and out. So it's still 2 times the distance, because I have to walk there and walk back, but it's not going to do it per container. It would do it for the set of 3 containers. Okay, so that's basically how the Tugger module works. So I'm going to go back into the Tuggers tab here, and I'm going to this time do my aisle flow calculation to get a little bit more accurate, and I'll generate routes doing that. I'm also, actually, I should have probably got it, and I'm going to change my random number seed. Let's see what happens if I do a random number seed. I don't have that many statistically derived pickups and set downs, but I do have a few. And every time I do this, I'm getting a new routing file. You know, if I change something, such as the random number seed, or such as, you know, having the traveling salesman problem use straight flow distance versus aisle flow distances, or if I move a location around, or I maybe go in and reassign a set of locations to a different driver. Okay, all those things will cause my study to be different, and then I recalculate my study, and I get my new diagram. Once again, this is using the straight flow analysis walking through the facility. I also get a number of stats, not only my statistics in here, which, by the way, also include my average trip time, my minimum trip time, all the typical statistics. But in the utilization tab, I can look at the total time I'm loading and unloading versus traveling. So you can see for this particular Tugger study, I'm spending more time handling containers than I am driving. So it kind of tells me that my focus, if I want to make an improvement in labor, is to focus on the handling, not necessarily making the distances shorter. The other thing I can do is look at time overall, and you can see here I'm busy, I'm idle, yellow. There's a lot of slots here where there's nothing going on. I don't even have a delivery. In that case, there's totally idle because nothing's happening. You can see that I'm definitely not time constrained here. I have no overutilized time. If I look at volume, you can see in this case, I did this on purpose, I got a couple of time slots for zone 2 where I have way too many containers that I can handle. Okay, and so I'm going to have to do a better job of distributing, leveling out the request or demand. Now, we don't do that automatically. You might say, well, why don't I do that automatically? Because Flow Planner is evaluating the system you give it. This is what I want delivered. This is when I want it delivered. This is the containers it is, and here's my Tuggers. So I can't assume that I have the entire 1 or 2 hours before this delivery window and the 1 or 2 hours after the delivery window to deliver these containers and smooth it out. I'm showing you that if this is what you want delivered, when you want it delivered, and these are the container sizes, and these are your Tugger capacities, and these are your location assignments, this isn't going to work for the Zone 2 driver. You're going to have to make some substantial changes somewhere to make this work. So the Tugger module is validating that you have a valid system, a stable system, and is also validating for you how well balanced your labor is per driver in this case, and your storage. So the times are, pretty spotty. Once again, I have a lot of extra time, but I obviously have a big problem in my Tugger capacity. So you're really managing 2 things. You're trying to keep your Tugger drivers fairly busy. In other words, if I have a 10-minute delivery, it takes me about 10 minutes to do the delivery, not much more, not much less. And you're also trying to make sure that when I do a delivery, the capacity of the carts is capable of handling the volumetric demand of the things I wish to deliver, right? Those are the two challenges you have, and that's what the Tugger module is constantly balancing. So in short, when you're doing a Tugger study, the real secret here is creating this delivery file. Now, this delivery file you may already have. For example, if you have an electronic system for part requests, let's say a push button in the workstations where people request parts to be delivered on the next Tugger run, you probably already have a data file of an actual day where these containers were delivered to these locations at these times. Use it. Take that file, import it in the system, and then, of course, play with assigning those deliveries to other drivers. So you already have the file. That's really why the Tugger module is designed to work the way it is. So, and then maybe you have one for yesterday and the day before and the day before that. So this is a great way for you to load the 3 different files as an import file. You use the same other 2 files, the methods and the locations don't change, but use this file and do your calculation. The other thing you can do is, let's say you don't have a facility. This is a new setup. So you don't have the benefit of having real live data that was logged and stored as the day went on. All you have are hypotheticals. Fine. That's what uniform distribution is for. So what you would do in that case is, for example, that this particular container has a demand rate. So let's say that I need to deliver a box of this product once every 2 days. Okay, so I would do container quantity 1 and probability of delivery 0.5, right? So that's just going to say every other day that container is going to get delivered. Now, it depends on your random number seed, whether that container got delivered in your first study or your second study, depends on where you put that, that information at. So that's what this is for. So you can just take your daily take rate, calculate your container take rate. How many containers of this part number are you consuming in an average day? And it's going to be some fractional number. It could even be a number like 0.1, which means you only deliver a container once every 10 days. That's fine. Uniform distribution, 7 a.m. to 3 p.m., 1 container with a 0.1 probability of delivery. That means statistically, it's going to show up about 10% of the time based on the random number that you select for your study. So that's why it's important, once you do this, change your random number and rerun your study. You're going to get a different answer. I do that, I hit generate routes. Now it's going to go into the statistics engine and generate different types of studies. I also want to mention that the Tugger module, if you go to the help, it's context sensitive help. When we go into here, you can see we do have, if I go to the tutorials, is probably the best way in the add-on Tugger tutorial. You can see in here, we do talk a little bit about those distributions. So we have a little bit of an example. This is actually the Tugger one that I went through. And in here, the reference section for Tuggers, identifying the deliveries. And in this case, I talk about the deliveries. Now, we've been talking about uniform, but there is also a triangular distribution, which basically means it can happen between 7 a.m. and 3 p.m., but there's a much higher probability that it's going to happen somewhere around 10 a.m. Okay, so now I've created a triangular bias. So there's a higher chance it's going to occur around a certain time, a lower chance other times. We also have something called a sequence delivery. So what if you have a situation where you want a delivery of this container, or maybe 4 of these deliveries every hour throughout the day, 4 deliveries. It's like engines or doors or something going to the line. So in this case, I'm specifying that, but I can also give it a probability of that's going to happen. But in this case, I said the 0.5 represents the time interval between deliveries in decimal hours. So this means I want 1 delivery, that's what the 1 means, every 30 minutes. Remember, this is decimal hours. And that's what it would give me. If I wanted 5 deliveries every 30 minutes, that'd be fine. Or if I want 1 delivery every 10th of an hour, okay, it's going to generate that. So that's a sequence. So you saw I can specify a specific time. I can give it a sequenced or fixed interval delivery. I can give it a statistically derived uniform delivery or a triangular delivery as well. And the online help spells that out, and you can also download and load the online help from our website. Well, hopefully this has been a helpful introduction to using the Tugger module in Flow Planner from Proplanner. As always, if you have any questions, feel free to contact us through email, or please use our new forms that we have on our website. Ask questions on the forums. We'll be happy to get back to you. Thanks again.